Hello, 8th graders. Welcome to the last video of distance learning and the last video of the year for you. So congratulations for making it through all of this. So the last two lessons are going to be lessons 12 and 13. We're starting with lesson 12 here, and we're starting to look at cubes and the relationship between the edge length and then the entire volume. So here we go. In activity 1, we're not really going to follow the directions here. I just want to talk about these first two equations. The first one, a squared equals 9. We've been working with that similar equation as we go along it with the Pythagorean theorem, but it's really talking about what number times itself gets you 9. And we've been seeing that the answer here would be 3. 3 times 3 equals 9. But now we're going to see things with a cubed exponent, or an exponent of 3. And what that means is what number times itself 3 times, in this case, gets you 8. And it might be some trial and error for a little while, and I do have a perfect cubes reference sheet for you, but in this case it would be 2. So the answer here would be b equals 2, just like this first one would be a equals 3. In activity 2 here, we're going to be looking at a cube and how to find the volume. So as a reminder, you find volume by taking length times width times height, but in a cube, all of those things are the same. So we're going to call those the side length. And what we can see is we could simplify that to volume is going to equal the side length cubed. In our table, our first one is saying that if the volume is 27, what is the length of the sides? This might take some trial and error, but I could figure out that if I had 3 times 3 times 3, that would get me 27. So 3 cubed equals 27. In the next one, we see this side length with some different notation. That is called the cube root. It looks like square root, but it's the cube root. And we're saying that if the side lengths are the cube root of 5, what is the volume? So the cube root of 5 times itself 3 times, well, that's going to equal 5. And we're going to be working with cube roots a lot coming up, so that'll make more sense if it's a little confusing right now. In the last row, we can see this equation, and I can notice that I took my side length and I cubed it. So my side length was the cube root of 16. If I multiply that by itself 3 times, I got a volume of 16. Activity 3 here is a card sort, and you are going to be doing that on Desmos. So when you finish the video, you can get started on that. In your lesson synthesis, I want to just talk about the second question and take some notes, guys. On this, what is the solution to x cubed equals 150, and what two integers would it fall between on a number line? This is our goal with cubed roots, just being able to reason through where they would fall on a number line. So I know that if x cubed equals 150, right, I know that I'm looking for what number times itself 3 times gets me 150. Well, let's think about some things that we do know, and again, use your perfect cube reference sheet for this. 5 cubed would be 5 times 5 times 5 is 125. So that's less than 150. 6 cubed would be 6 times 6 times 6, and that's 216. So I know that x is going to be between 5 and 6. Probably a lot closer to 5, so maybe something like 5.2. Okay, in lesson 13 now, we are going to be working more with cubed roots. I want you to draw this number line, including the perfect cubes underneath. It's going to be a great reference as we work through this lesson. This is also in your perfect cubes reference sheet that's listed on Canvas. Activity 1, you're deciding if these are true or false. Before you do this, I'm going to give you an example. What if I have the cube root of 8 cubed? What that means is the cube root of 8 times the cube root of 8 times the cube root of 8, and the cube root of 8 is 2, so this would be the same as 2 times 2 times 2, and if you notice, that is 8. And so you kind of use that as an example as you work through and decide which ones are true and false. Here's the answers for true or false. I just want to talk about this last one. It's easier on this one if you simplify both sides. The cube root of 64 is 4, and 2 cubed is 8, and so those two things are not equal, so it's false. Okay, activity 2 here is really getting at the heart of what we want to be able to do with cube roots. We want to be able to estimate where they would be on a number line so we can estimate their approximate value. Yes, you can use a calculator to figure out decimal approximations, but we really want to reason through what's going on here. So here we go. Number 1, the cube root of 5. Notice I've drawn a number line here, included the perfect cubes. Please do that as well. And the cube root of 5, I can see is going to be somewhere between 1 and 2, slightly closer to 2. So there's the cube root of 5. The cube root of 23, I can see is going to be somewhere between 2 and 3. It's going to be a lot closer to 3 than to 2 because 23 is closer to 27 than to 8. Go ahead and try the next two and start again when you're ready. Okay, here's the last two. Cube root of 81 is going to be between 4 and 5, a little bit closer to 4. And the cube root of 999 is going to be super close to 10. In activity 3, we're going to be looking at the number line again. Make sure that you've included your perfect cubes on your number line. It makes this a lot easier. And we're going to decide where x, y, and z fall. The first thing to talk about is that if x cubed equals 5, that means that just x alone is going to equal the cube root of 5. And same thing for y. If y cubed equals 27, that means that y alone is going to equal the cube root of 27. Do the same thing here for z and then place them on the number line. All right, so here's what we end up with. Here's the position of x, y, and z. And then number 2, plot the negative cube root of 2 on the number line. Well, that's going to be right here in the negatives, just on the other side of the cube root of 1. I do want to show you guys how to find a cube root using a calculator, just in case you need that decimal approximation. For the most part, you won't need the calculator, but if you do, here it is. This is your Desmos scientific calculator. You're going to look for a button that looks like this. This is the square root. This is going to be where you can do the cube root. It says n. So when I do that, I would have my symbol that looks like this. I could put a 3 there for the cube root, and then I could go underneath the radical, we call that, and I could see that the cube root of 64 is 4. If I do something different, like the cube root of 60, now I have that decimal approximation. If they're not perfect cubes, they're going to be irrational numbers. So for the most part, we are just estimating, but if you do need a calculator, that's how you do it.